Okay, this one is the this is the weight of the top, and this is the radius. Sorry, this is the radius. If you look at here, this is the weight, and this is the radius, and we need to multiply with sine of this, sine 60, in order to find the radius, actual radius for this moment. And that's why we have this component, and this is equal to the one that I said just now. This is for the moment of inertia I, and this is moment of inertia Iz, which is given in the questions. And we just put in the values, and finally we can get this equation. It's a quadratic equation. So this is the symbol that we want to know the value, the precession angular velocity. So by solving the quadratic equation, we can get two values. This is for the high precession, and this is for the low precession. Now we go to the second example. We have this configuration. We have 1 kilogram disc spinning about its axis with angular velocity WD, this one 70 radian per second. The block B has a mass of 2 kg, and by adjusting its position S, this one can change the precession of the disc about its supporting pivot at O. So if we change it, the precession will change. So the question asks to determine the position of S, which will enable the disc to have a constant precessional velocity equal to 0.5 radian per second. So how to find the value of S? So in the free body diagram, the origin for both XYZ small and XYZ big is located at point 0, which represents a fixed point for the disc. This one. So since this this shaft is horizontal, therefore we consider the nutation angle is 90 degrees. So we can use the simplified equation, this one, and this is the angular velocity of the precession. So we just key in the value, but remember we need to consider the weight. This is the distance. Okay, this is the distance, and this is the weight of the gyro, this one. So 9.81 Newton, and the distance is 0.2. So minus F 0.2. So F is unknown. So since we want to have the precession speed or angular velocity equal to this value, 0.5 radian, so we put this value inside this equation. So 0.5, and we can calculate the Iz, and we put the value of omega z here, so we can find the value, the additional value inside this moment about x axis. So this is the value that we want to add in order to get the precession angular velocity equal to this 0.5 radian per second. So now we want to calculate the value of S, the length. So the weight is 19.92, the block mass. So time as we will get this value, the 10 Newton that we got just now, and time the, so we need to balance these two. Therefore the value of S finally we can get it, which is equal to 102 millimeter. So that's all for our lecture. I wish you all the best for the exam. Thank you very much. Assalamualaikum.